This conference will now be recorded.
Joshna, Prasad, Tirupati.
Yes, sir.
Okay. So fine. So today we'll talk about the new algorithm from the machine learning. It could be decision tree. Basically, this particular decision tree we can use for both regression and as well as classification. Okay, that what the information could be there inside of here. This is the classification two-step process, learning the steps and prediction step. So only we have only two steps in the classification. One is first it can learn, then after you can go for the prediction. In machine learning, actually, in the learning step, we can create the model with help of some training data. So that could be the step for the learning. After you learn, after you creating the model, then it can be used for some prediction for any kind of new data. So that is the second step. Okay, so here the decision tree is one of the easiest and popular classification algorithm, and we can go for understanding this particular algorithm here. See, if you go for decision tree algorithm, so basically this we can use for and both classification and regression problems. So with help of the decision tree, we can solve the two kind of problems. One is the regression problems as well as classification problems. Regression regression problems means here the target variable, it could be continuous. When the target variable, if it is the classification or categorical, then I can go with the classification. Okay, so even those two kind of problems we can solve with the help of the single algorithm, which is decision tree. So the goal of using the decision tree, we can create the training model as a learning step. We would like to go for creating the training model, right? So with help of the decision tree, we can create the training model. After that one, we can use for prediction. If the target variable is continuous data, then we can use for regression. If the target variable is the classification, categorical data, then I can go with the classification. Okay. So here we have some kind of decision rules from the prior data, that means training data. So next point is in decision tree, for predicting the class label for record, we start from the root node. See, actually how the decision tree is working, it was very simple. So if we have a different kind of features, it was splitting into different nodes. Okay, the top level, the top node we are calling it's a root node. The top node we are calling it's a root node. The entire tree we are calling it's a root tree. So when we compare the values of the root attribute with the record attribute, on the basis of comparison, we can flow the branch. That means we can splitting into different nodes with the different rules, different kind of decision rules. So decision tree means it was very simple thing, guys. It was making the data into different trees, different nodes. From root node to leaf node, it was on the basis of comparison, we can flow the branch corresponding to the value and jumping into the next node. I hope you clear, right? If you're not understood about this one, I can explain one more time. Here it is not explaining anything, guys. We have some features, we have some attributes. Okay, so if we have attributes, if we have the four attributes, so based upon this particular four attributes, from this particular four attributes, we can consider as the one as the root. Then we can split into different condition, different rules. Okay, once if you're splitting, and so to from your root node to leaf node, we can do different kind of splittings, and each one it could be the node only. This is also node, and this one also node, and everyone is the node, but this is the root node. And the last stage, what we have it, if you are not unable to splitting into different other parts, that kind of node we are calling it say leaf node. From root node to leaf node, We can split different steps, different nodes, different branches based upon some rules. What are the rules and everything that we can understood for the continuation? Okay. Is there any question regarding about this point? Is there any question, guys? So what are the type of decision trees we have it? What are the decision? What are the type of decision trees we have it? So basically, you already know it. There is a two type of decision trees we have it. One is the one type of decision tree. It can be used for to solving the regression problems. That means when the categorical data is the continuous, then the second algorithm, that means continuous variable decision tree, categorical variable decision tree. Categorical variable decision tree means for solving the classification problems, and continuous variable decision tree means to solving the regression problems. Based upon the type of the target variable, we have the two type of decision trees. One is categorical variable decision tree, second one is continuous variable decision tree. Okay. So let's go for understand small examples. Let's say we have a problem to predict the whether a customer will pay his renewal premium with an insurance company, yes or no. That means here the problem statement is, so every year you are paying some kind of insurance. Okay, you are paying for some amount for insurance. So based upon our information, based upon the customer information, you would like to go for predict whether this customer will go for the renewal or not. Okay, so that kind of problem statements we can solve, but it could be the classification. So here the categorical variable is yes or no, so that here we know that the income of, so that is the one. So here yes or no, right? Here the categorical variable is here this is the target variable is categorical variable. Okay, here we know that the income of customers is a significant variable, but the insurance company does not have income details for the customer. Now we know this is an important variable, then we can build a decision tree to predict the customer income based on occasions, products, and various other variables. In this case, we predict the value of the in this case we are predicting the value of the continuous variable. Okay, so if you go with you are going to predicting the some kind of continuous variables, continuous target variable, then we can go with the continuous variable decision tree. If you go for predicting the classification information, then we can go with the categorical variable decision tree. So that's a very simple thing. When you're talking about decision tree, when you're talking about decision tree, we need to know some terminologies, important terminologies related to decision tree. When you're working with the decision tree or random forest, as XGBoost, whatever it is, so the base model is decision tree only for every time. So that we need to know some kind of terminologies. If you don't know these terminologies, it can be it can be problem while implementation time. So the first thing is that root node. So Deepika, tell me what is root node?
The basis on which we start the decision tree, the starting point.
Yes, the first very beginning node, right? The root node is nothing but, so it's representing the entire population or sample, and this further gets divided into different mode or more homogeneous sets. Okay, C, which means that the beginning, the starting entry, So if you go with this one, it can be indicating that its entire population. So it was dividing into different groups, the two or more groups. It may be homogeneous or it may be heterogeneous. Heterogeneous in the sense different other nodes, other types, nothing but. So splitting means the process of dividing a node into different other nodes. So for example, the first node is some x1 variable, okay, and we have the n number of x variables are there. After that one, we are dividing into, okay, three nodes, right? You are dividing into three nodes. So when you're dividing into three nodes, this is the process we are calling it as splitting. Splitting is nothing but the process of dividing a node into two or more subnodes. Decision node in the sense when a subnode split into further subnode, that means this is the node, again you're splitting into another node. Okay, this is the nodes we are calling it say decision nodes. When a subnode split into further subnodes, then it is called decision node. Clear? And what is terminal node? So for example, here we have some decision nodes. Here we have some decision nodes. You may have n number of decision nodes. That means you may have n number of steps of decision nodes. So this stage also decision nodes. This stage also decision node. So whenever a node it is unable to splitting into another node, then this is the node we are calling it say leap node or terminal node. Clear? Is it clear? Is Shravani any problem ఊరికే? Okay. So if you want to note this one, just note this four nodes, four terminologies. It may be interview questions also, guys. Just note this four terminologies. After that one, I can explain some other information. Done?
Yes.
So now let's go for understanding the few more terminologies. For example, you already split your entire data set into different nodes as a tree. Okay. So here pruning is the technique. It can help you to remove the unwanted nodes. Okay. Pruning, when you remove the subnode of decision node, this is the process is called pruning. You can say opposite of splitting. Splitting means you're trying to splitting into another node, right? But pruning, what you can do, you if you want it, you can able to remove this particular. You can try to remove unwanted subnodes. So when you remove the unwanted subnode, that means it's a pruning. We are pruning. It can help you to reduce your decision tree levels. Okay, you're trying to remove the unwanted decision nodes or subnodes. Okay, so next one is branch or subtree. That means if with the help of the one decision tree, you're splitting into subnodes. This is the block or this is the stage. This entire information, the entire tree, the entire subtree, we are calling it say subtree or branch. Parent or child in the sense, parent means the base or whatever the node we have it, which is try to convert, it was try to splitting it, then that node we are calling it say divide into that node we are calling it the parent node, and whatever the node which was splitted by another node, then that node we are calling it say child node. Note this particular technologies or terminologies. Okay, now we can see this one whatever I explained. So you can see this graph, and this graph is giving the entire information what I was explained. The first entry node we are calling it the root node, and the process of dividing into subnodes that we are calling it the splitting, and the node what it is splitted, and whatever it can be splitted to another node, then that kind of node we are calling it a decision tree. And whatever the node which is unable to splitting into another node, then that the node we are calling it a terminal node. And the entire subtree of one particular decision tree, if it is try to dividing into another node, the entire tree we are calling it a subtree or branch. Okay, note this graph, note this graph guys. Hello. Done.
Yeah, done.
Okay. So that is all. Okay. Yeah. This is what our explanation. The next one is assumptions while creating the decision tree. So whenever you try to creating the decision tree, we need to go for do some kind of assumptions. So this assumptions could be there in every algorithm. Even it is the even it is the linear regression, even it is the regression, logical regression, logistic regression, decision tree, exhibits, whatever it is. But there is some kind of assumptions we have it. Below are some of assumptions we make while decision tree. See, this is very important question, guys. If you go for interview, if you said that I applied the decision tree on my model for creating the predictive model, that kind of situation, you might be get a question. What are the assumptions you read for decision tree while implementation time? Okay, so the assumptions are in the beginning, the whole entire training set is considered as the root. This is one assumption. Second assumption is feature values are preferred to be categorical. If the values are continuous, then they are described prior to building the model. Okay, and records are the distributed recursively based on the attribute values. Order to placing attributes as a root or internal nodes of the tree is done by using some kind of statistical approach. What are the statistical approach we can use for splitting the data into different nodes? Okay, so there is different techniques are there. The techniques are, I can show you what are the techniques. Ah, just missed it. No, yes. Attribute selections. So entropy, okay, Guinea, information gain, and information gain, Guinea index, Guinea index, Guinea ratio, okay, Guinea ratio, and reduction in variance, chi-square, chi-square, okay. So these are the techniques, okay. So see, for example, if we have n number of attributes are there, if we have n number of attributes are there, if the data set consisting of n number of attributes, then it was deciding which attributes to place as the root node, and what are the different levels of tree internal nodes. And it was very complicated steps actually, by just by selecting as a random, and it is not possible. You can select as random, but you won't get as a good accuracy. To overcome that kind of issue, so we can go with the selections, features attribute selection. Okay, so we are getting, so to solving this kind of attribute selection problem, the researcher worked on devised into some solutions. They suggested to use some kind of criteria. Okay, so entropy, information gain, Gini index, Gini ratio, reduction in variance, and chi-square. These are the techniques. These are the techniques. Okay, these are the techniques will help you to selecting the which attribute as the selecting as a node. Okay, note this example. Sorry, note this information. For selecting the attribute selection problem, to solving the attribute selection problem, we can use some kind of solutions. We have some kind of techniques or algorithms are entropy, information gain, Gini index, Gini ratio, reduction in variance, and chi-square. If it is done, please let me know, guys. Hello.
It is done.
Okay. So I think you are thinking about what is entropy, what is information gain, and what is the Gini index. Okay. So you are getting some kind of doubts, right? So entropy means, so which is like randomness. Okay. So randomness in the sense, So you just read this one. Entropy is the measure of the randomness from the information. See, this is the randomness. If it is near to zero, that means entropy could be the less. When the entropy could be the less, so there is no randomness. So when there is no randomness in the tree, that means the model is giving the best one. So less entropy is giving the higher accuracy. Okay. So information gain means which is giving the more information. So when entropy is less, then information gain will be high. So this each and every method I can explain you, or I can explain with the definition wise, as well as with how we can able to calculate it with the mathematical things with the help of this one only. So this is main important topic. So entropy, information gain, Gini index, Gini ratio, and reduction in variance chi-square. These are the technologies, or these are the techniques. These techniques will help you how the decision trees was splitting into another nodes. So if you know this one, then the decision tree concept will be simple. Otherwise, it will be complicated. How the decision tree is splitting into different nodes. So okay, so that information will catch up in a next class. And before that one, I want to tell you there is different kind of decision tree algorithms we have it. You can see the algorithm selection is based upon the type of target variable. So one is the ID3. So ID3 is the ID3 is the ID3 is the one type of decision tree. So extension of D3. Okay, C40 C4.5 successor of D3. ID3 successor of ID3. And cart means most of the decision trees are working in based upon the classification and regression tree only. And we have one more thing is child. Okay, so chi-square automatic interaction detection performance multi-level split when computing the classification trees. And we have the Mars multivariate adaptive regression splines. These are the 5 different type of decision tree algorithms we have it. So these 5 algorithms can be worked based upon this concepts only: entropy, information gain, Gini index, gain ratio, reduction in variance, and chi-square. Okay, clear my point?
D3 is also a kind of decision tree, is it?
It's absolutely correct. It's the type of decision tree.
Okay.
So that each and everything will will understood by next class.
Okay.
Good enough. Bye. Take care.